Hey everyone, welcome to part 2 of the Singularity Beast Resurrection build log. So that's the name that I've decided on for this build log. Even though this system is not going to be called the Singularity Beast anymore, it does have some similarities. It has some of the parts from the Singularity Beast. Anyway, as I said at the end of part 1, part 2 is going to follow directly on from part 1. So here we go. Okay, now looking at the front of the build, so you can see the front of the coolant reservoir. It really looks good. It suits the build really well. We'll actually be only using one side of the reservoir, like all the flow happens on this side, but I have opened up to this side so that, you know, that side will fill up as well, so it'll look like the whole thing is being used. And you know, once that switch panel is in just here, it's going to look awesome, because this switch panel also has red LEDs in it. Like underneath the transparent military switches, there's red LEDs on the actual switches themselves, so it looks great. So just moving around to look at the wiring here. It might look messy to you guys, but there is the hell of a lot of wiring here. You know, all the lighting, powering up the pumps and everything else, you know, all the wiring is done. Like the 8-pin going up here to the CPU, the 24-pin motherboard power. I've put the wiring in for the graphics cards, so no more wires need to be added, you know, except for a few LED wires. But yeah, this is it. So we've got a Bits Power X station over here. This is for the, well, partly for the lighting. It's for all the LED strips in the build. So that will be switched on and off via the military switches. And then on the other military switch will be this Bits Power LED station, which will control all of the LEDs. Now, most of the mess here is actually because of the fan controllers. The way the fan controllers are designed is so that, you know, you get a whole bunch of wiring that comes with the fan controller. It's all unsleeved. It plugs into the backs of both the fan controllers, and all of that is here for eight fans. You know, they're 4-channel fan controllers, so 8 channels altogether, and all of those channels are just here. Some of them are connected up here. The 3 fans in the top is connected to one fan controller, and the 4 fans on the back of the build are connected to the other fan controller. So I think the top fan controller does the top rad, bottom fan controller does the back rad. I think that's the way we did it. So yeah, then we got the other ones coming back to here, connected up here, and those 4 fans connected up there are the 4 fans on the back of the build, the Feather True Work mid speeds. So I'll just give you a look at those. They're a nice fan. They come with these guards, so incredible performance out of those fans. The pressure and CFM is just massive. So you can see how they're wired up down there. I've actually put this piece of tubing here because these coolant adjustable radiator mounts, they do allow the radiator to sag a bit because there is a lot of weight down there, and as you can see, it's not in the middle. Like if you put this, if you mount the radiator so that this is in the middle of the radiator, then it's okay, but obviously on a quad radiator I can't do that, so I've put that piece of tubing in there. This little LCD poster actually comes with the motherboard. It posts error codes during boot if there's a problem, or temperatures, or the time, I think, so depending on how you configure it in the BIOS. You guys are probably wondering what the hell I'm looking at here. This is actually a system that I built quite a while ago now for the same mate that I'm building the Singularity Beast Resurrection build for. So already in this build log I've stripped one system, the Singularity Half-X build, which you saw me strip in part 1. Well, now we actually get to strip another system. So yeah, this is the Cosmos S build. I'll put a link on the screen to the video, the specifications video that I did of this build quite a while back now. But yeah, basically we're going to be draining this water cooling system. This is just a budget build that I did. It has some quite nice parts in it though. I'm not going to go over all the specifications now because I don't have time. You can check out that video for all the specifications and details. But yeah, basically we're going to be draining the water cooling system, and all that we need out of this system for the Singularity Beast Resurrection build is the graphics card. Just one of the graphics cards here, which is a GTX 480 with a EK nickel acetal water block on it. So I'll give you a good look at the card once I've got it out. I'm going to be using the BitsPower Crystal Link system instead of the normal EK FC bridge system that I'm using. Some of you will know what I'm talking about, but those of you that don't, when you're connecting up multiple graphics cards in either Crossfire X or SLI and you're water cooling them, you need to be able to connect all three cards, you know, preferably without using tubing, because using tubing looks horrible. It's hard to set up. It's not a good way. There's better ways of doing things out there, and this is one of them. Alright, I'm installing the graphics cards. You can probably see Matt working in the background there. It's in. And now I'm just going to wiggle them around a bit, make sure they're all in the slots properly, you know, all clicked in. And yeah, now I can go ahead, put the screws in, wire them up. Okay, that's it. The graphics cards are in. I've also finished tubing up the graphics cards and finished the wiring, installed the sound card. The system is actually now ready to go. I've also done a few more things, such as installed the switch panel, but I'll give you a close look at the graphics cards, the Tri-SLI GTX 480s. And you can see the BitsPower Crystal Link configuration that we've done. I've also wired up the graphics card. I'm really not happy with these stock cables that come with the Silverstone Strider 1500 watt power supply that we're using. Just because, you know, they're not sleeved all the way to the end. The sleeving is, you know, you can see straight through the sleeving. Yeah, so what I'm going to be doing when I upgrade this system, which we're actually going to be doing pretty soon, I will certainly be replacing those cables with extension cables, probably Bitphoenix. This cable here lights up the back I/O panel, and there's another cable up there that plugs into the motherboard. You can see it just in there. That goes to the LCD poster. So you can see it's a single 8-pin EPS connector there, and these wires that you can see coming in there, I've just cable tied them to that bolt there that holds the EK Supreme HF, and they go to two LEDs that into the EK Supreme HF, and they're red LEDs. I'm actually not sure of the brand, but I got them made up custom with 2-pin connectors so that I could hook them up to a BitsPower X station. Two more LEDs just there, they're red LEDs, they're all 3mm LEDs, so they go into the EK water block on the memory. There's no LEDs on the Northbridge, but that lights up just there, and so does the sound card. The sound card lights up blue, and I think that lights up white. So we've actually got a nice combination of red and blue lights in this system. Considering that the sound card lights up blue, I've got a blue LED strip just behind here, and there's a red LED strip just there. So I'm not sure how, this is actually the lighting that I've left behind from the Singularity Beast, so I just haven't bothered to remove it because I think it's going to work pretty well with this system. I decided not to put a fan there. I mean, it does bolt in underneath. I think that's something that we'll probably add actually when we do the upgrades, because that's a 140mm fan. That'll put some nice airflow onto the graphics cards and also up into the top rad there. So yeah, it'll bring some airflow through from the bottom, but there is the fan there and there's one behind there as well, but that's for cooling the hard drives, and then that air basically gets sucked through here and through the back of the case, and it actually comes around, it comes through the other side. You can see this ventilation that runs all the way down the side here. I've got a temperature sensor hanging out just here, and I'll show you that shortly. I've got 3 temp sensors in the build. You know, they run off the motherboard. That there's operating temperature 1, 2 and 3. So you can see 2 of them are plugged in there, and they come around. One of them goes around the memory and up to the top of the memory just there to give us the memory temperature. I'm not sure if you can see that there, but basically it goes in between the memory modules there and touches the memory itself. There's another one, you can see it goes around the top of the 24-pin motherboard power connector just there, and I've got it hanging down in the inside of the 24-pin motherboard power to hide it. So yeah, you can see these LED cables nice and hidden behind the 24-pin power. But that temperature sensor behind there is to give me to give Matt the ambient temperature of the air inside his case. And then the one that I've got hanging out the back of the case is obviously to give the room temperature. You can see it just there. So that way, you know, you'll know the difference between the outside room temperature and the case temperature. And then also, yeah, the one on the memory is because that's really the only way to get the temperature of your memory, because there's no temp sensors on the memory itself. So now looking around the front, you can see the switch panel, the military switches that we used. So they light up red, they're going to look great. Okay, I'm going to go ahead and fill the loop now. So one thing that I do, and some of you are going to think this is a bit crazy, I fill the loop at the same time as boot. So the other option is to short the power supply and unplug everything so that it doesn't boot the system, and basically, you know, instead of using the power button to boot the system, you short the power supply, and, well, you don't like short it out, but you short the same wires that the power button shorts, okay? So basically what you're doing to the power supply is the same thing that the power button is doing. And then all you do is you only connect up the pump, you don't connect up anything else, and you fill the loop while the system is dead. The system's not even powered up, not even running. And this is so that if you do have a leak, you don't short the system out. So I don't even bother with this, because I've actually lost count, but I know it's around 100 water cooling systems now. Yeah, I've got a lot of confidence doing this now, filling the loops at the same time as boot. Okay, all ready to go. So yeah, you'll be able to see everything that's going on here. You can see the reservoir, you'll be able to see that filling up. You know, it is in the corner, but what I want you to mostly see is the system. So keep an eye on the tubing filling up, on the reservoir filling up. I'm just starting to syringe into the reservoir now. This is the first time I've used one of these coolants reservoirs. I've never liked bay reservoirs at all, but when I saw these reservoirs, you know, the reason I like them is because you can fit 2 pumps and it's 2 reservoirs as well, which, you know, is breaking a lot of rules. It's amazing. So yeah, I thought I was definitely going to try these out sometime. Okay, this reservoir seems to be, it seems to be moving really slowly. Like the pump is not moving much coolant yet, and it's unusual, but you know, it could just be this reservoir, the way it works. I've heard people say that it's really hard to bleed. So I've put quite a bit of coolant through so far, but it should be circulating by now. But as long as the pump even has the slightest amount of fluid in it, then the pump is safe. So but normally if I was using a cylinder reservoir, it would definitely be circulating by this point. Starting to circulate. That's about the slowest fill up until circulation I've ever seen in any water cooling system that I've done, and that's because of this reservoir. It sounds pretty ugly too, but that's just the pump sucking, you know, little bits of air, which is okay. Okay, I ran into a couple of problems with this reservoir. Now, I wasn't really keen on this reservoir right from the beginning, but the whole idea was to have a clean loop. And that's what the whole idea is with this reservoir, the way it's designed. You know, it crams 2 reservoirs and 2 pumps into a couple of drive bays, which is excellent, you know, in theory, but seriously, the flow is horrible. Like, I spent probably 10 minutes trying to get the air out of the loop, and yes, that is not very long at all, but I'm not talking about lemonade, like tiny little bubbles. I'm talking massive airlocks in the loop, and seriously, the pump just couldn't suck any coolant unless I filled it right to the brim, and you know, and then it was just about overflowing. And when you get bubbles coming back, they pop, and it kind of sprays a little bit of coolant around, and it keeps doing it. So, you know, you get a bit of a spill happening. So that kept happening. That was really annoying me. The fact that it still had huge amounts of air in the loop, like up in this tube here, after 10 minutes, you know, that's a reason to remove this reservoir and not use it at all in this system. I'm not happy with it at all. We've had a bit more of a look at the build. Like, it's all been rush with this one. It's been on quite a tight schedule, so we haven't had a lot of time to think about the aesthetics and things, but I think a reservoir in front of that, just in front of that LED strip just there, would be absolutely perfect, up in that blank spot there. Okay, I've finished changing the build around. It was an absolute nightmare to drain the other configuration. The reservoir was just impossible to drain, even with the quick disconnect that we had in there. I actually ended up just cutting one of the tubes going down from the radiator to the coolant's reservoir, because if you remember, the coolant's reservoir was in the bottom here, and yeah, anyway, cut one of the tubes. We didn't spill any coolant, it was all good. I got Matt to put a container in underneath and catch all the coolant. I actually had to blow a lot of it through. So yeah, I didn't bother showing you that draining process, because it certainly was not a standard draining process. It was just, you know, had to be done because of the problems that I had with that coolant's reservoir. I'm going to look into what happened. I think it's just the reservoir itself. The flow restriction was just, you know, ridiculous. I just could not believe how bad the flow was. Very surprising. I thought they were... Anyway, I shouldn't really talk about the bad too much, but all I can say is that for this particular configuration, this particular build, that reservoir just, yeah, did not work well. A cylinder reservoir is a lot more suitable. It was actually, you know, my first time trying out that particular reservoir. I don't like bay reservoirs at all, and I went off them years ago and started using cylinder reservoirs all the time. But when coolants managed to fit, you know, 2 reservoirs and 2 pumps into a single reservoir, I thought I'd give it a go. And I mean, to sacrifice a little bit of flow to save that much space is really not so bad. But, you know, there was also back pressure. Like, I guess it's, you know, because I had the reservoir pretty low down, like you can see it's down here, and there's a lot of radiator capacity above it and also tubing. So basically, once you've got the loop full, the only time you can, you know, take the cap off the reservoir is when the loop is flowing. If you take the cap off when the loop's not flowing, yeah, you get a lot of backflow out of the reservoir, and yeah, if you do that, it'll drain coolant everywhere, because, you know, it'll start emptying this top rad, part of the back rad, and that top tube up there, you know, tied up onto that top rad. So anything above the reservoir basically will start draining out of the cap. So, you know, that kind of back pressure I don't like either. It's another good thing about a cylinder reservoir. So yeah, a lot of reasons, but mainly flow. That was the big one. So this is the new config, and we've just started filling it up. Just about to hit the power button actually and start again. So this will not take long to fill at all. I'm going to show you the entire process. So I'll just go over exactly what we've changed. I'll just cut down this tube in length a bit. Oh, that's right. Before we had the quick disconnect on this tube, and it went up to the back of the res, I'm pretty sure. So it's actually been about a week since we were last working on this system. We've had a bit of a break, so just coming back to it now and yeah, doing this new config. Anyway, so we've got a 90-degree single rotary here, oh sorry, dual rotary there. Underneath there I've put a 5mm extension fitting and a bits power D-plug. So it's basically a quick disconnect, but it's not a no spill quick disconnect. So it's just there for once you've drained the system, then you can pull it apart. And also I put that there so that I can rotate the reservoir, because the reservoir is offset. There's 3 openings at the bottom there, and I wanted the offset to be facing that way so that I could connect this up here. You know, if the offset was on the other side, then I'd obviously have to connect this up over here, and I don't want that because then it's too far away. So yeah, needed a rotating fitting, and a D-plug is always good in a situation like that, because it, as well as helping the rotation, it helps you pull the system apart when you need to, you know, drain it and change things around. So got a bits power mod kit on the pump. I've got the matte black back on it, you can just see it through there, and yeah, you can see I've got the transparent plexi front, so yeah, you can just see it through there. I've also changed the wiring to the graphics cards, so I've now got Bitphoenix black extension fittings to all 3 of the graphics cards, so that looks a hell of a lot better compared to the cables that come with the Silverstone Strider 1500 watt. So very happy with that wiring there now. They're all single sleeved, and the sleeving on these Bitphoenix cables is just beautiful. I'll just give you a close look. It's very fine weave. So also very happy with this coolant color. It's a mixture of red and black, and I'm going to try and keep this color, you know, as I'm filling the loop. There is a lot of coolant to put in here, so basically at the end, when I'll just put all red in it to start with, and then at the end when the reservoir is about half full, I'll put another dash of black in it, let it circulate a bit. Anyway, this tube here, I've got a 90-degree single rotary on there, on the front of the pump there, and that goes straight up to the top 360mm radiator on the other side there. And that, I can't actually show you that, all you can see is the tube going up there, but there's actually a compression fitting, and it goes straight into a compression fitting. There's no other fittings up there, no extensions or anything. So you can see now, I'll go, the full circulation comes out of the reservoir into the pump, out of the pump up here into the top rad, the 360mm rad, out of the 360mm rad and all the way along that long tube there, tied up to the rad there, into the back rad, the 480, out of the 480 into the CPU, out of the CPU into the North Bridge block, and then out of there into the memory block, and then out of the memory block into the graphics cards, and then through and then back to the reservoir. So there we go. It's now time to fill the loop. You're going to have to pull it out really fast when I tell you to. Pull it out. There we go. That's probably the only time we'll have to do that. From now on it should run, because it's already started circulating. Like it's already, as you can see, it's already coming back from the bottom of the graphics cards to the reservoir, which means, you know, full circulation has already happened. Now it just needs to blow all the air out of the loop. And with a cylinder reservoir, a high flow system, powerful pump, that happens very quickly. You know, I've had questions about bleeding a loop, like doesn't it take an extremely long time, people saying things like that, but you watch, this thing will be almost no air within probably 3 minutes. It'll just have lemonade in it, and seriously, all the lemonade in this loop, it'll probably take up about, I don't know, 2 or 3 inches, like 2 inches of the reservoir. Like that's how much you'll have to top it up once all the lemonade has come out of the loop. Okay, you can plug it back in. So this time it's going to suck that reservoir dry very, very, very fast. There it goes. Alright, looks like we're going to have to do it one more time, Matt. Pull it out. So that would definitely be the last time. You can plug it back in again. I'm just going to hit the power again. As I've said, it's only getting to the BIOS, so it's not as if we're switching it off halfway through boot and potentially corrupting the OS or data on the drive. You know, we're pulling the plug when it's still in the BIOS, which is not doing anything to the system, any damage to the system whatsoever. So let's go again. There we go, full circulation. Alright, there we go. Another high-end water-cooled build finished by Singularity computers. Okay, just a shot with the side panel on. If you're after custom decals, check out the information in the video description. You can get different colors, fonts, whatever you want, and get them made up and sent out to you. So there we go. Now I'm going to give you a look at some performance results.